Hey, welcome back. So we've done a unit on probability and we've done a unit on frequency distributions. Now we're going to combine those two concepts and we're going to talk about probability distributions. So a probability distribution is a table or an equation that links each outcome of a statistical experiment with its probability. Let me show you an example. So I'm heading off on a ski vacation, and the weather guy says that for each of the next 3 days, there's a 40% chance of snow, which means that there's a 60% chance of sun. As a skier, I want to know the likelihood of getting some good fresh snow to ski on. So I use this tree diagram to find all the possible probabilities over the 3 days, and then I summed it up in this table. So this table lists the possible number of days of snow and the probability of each. Now, the outcome of a probability experiment is usually a count or a measure, and we call this outcome a random variable. Quick review. Remember when we talked about types of data? There's two main groups, qualitative and quantitative. Qualitative can be split into nominal or named, and ordinal or ordered. Quantitative data can be split into two main groups also, discrete, which is countable, and continuous, which is measurable. Let's practice that just a little bit. So are these discrete variables or continuous variables? The number of students in Mrs. Saunders' statistics class. That's something we can count, so it's discrete. What about the height of the students in Mrs. Saunders' statistics class? Well, height is something that's measured, so that's a continuous variable. The temperature in Mrs. Saunders' classroom? Well, that's also measurable, that's continuous. And what about the number of tardies in each statistics class? That's definitely countable, and that's discrete. So let's talk about some of the properties of probability distributions. Probability distributions, like those variables, can either be discrete or continuous. The probability of each value is between 0 and 1, inclusive. Mathematically, that looks like this. P of x has to be between 0 and 1. And the sum of all the probabilities is 1, which means we're covering all the possibilities. Let's practice that with this probability distribution here. It says determine the probability distribution's missing probability value. Now remember, all the probabilities have to add up to 1. So we take all the probabilities that were given, add those together, subtract from 1, and we can find that the missing probability is 0.26. Just like with raw data, we can find descriptive statistics of probability distributions. We can find the mean, the variance, and the standard deviation. The mean of a random variable represents what you would expect to happen. It's also called the expected value. Although probabilities can never be negative, they have to be between 0 and 1, the expected value can be negative. Again, a little bit of review. When you're working with raw data, in order to find the mean, you add up all the data entries and divide by the number of data entries. Then you can use a table such as this one to find the standard deviation. We're going to do something similar with a probability distribution. So here's a frequency distribution that shows the number of cars per household in a local neighborhood. We're going to construct a probability distribution from this, and then we'll find the mean, variance, and standard deviation. First thing we need to do is figure out how many total households we're dealing with. So if we add all those households together, we know that we're dealing with 644. Now we're going to use a table similar to what we did before to find the mean, variance, and standard deviation of this probability distribution. So first thing we need to do is find the probability of each random variable. So to find the probability of the random variable 0, or 0 cars in a household, we look at how many households have 0 cars, which is 10, and we just put that over the total households, 644. So that's 0.016. For the random variable of 1, we find out how many households have one car. So that's 215 out of 644, which is 0.344. And the same process for the random variable 2 cars per household and 3 cars per household. So we found the probability of each random variable, and we could graph that into a lovely probability distribution. But we're going to continue on to find the mean. So to find the mean, we're going to take x times p of x for each of these. So 0 times 0.016, which is basically 0, okay? And then 1 times 0.334, which is 0.334, 2 times 0.489, which is 0.978, and 3 times 0.161, which is 0.484. So pause the video at any time if you want to write this down or catch up on anything. Next thing we're going to do is add all those things together. So the sum of x times p of x is 1.797, and that's our mean. Now to find the variance and the standard deviation, we need to continue on in this table, and we can use the top as our guide. So the first column says take x minus mu. So we'll take 0 minus 1.797, get negative 1.797. And then 1 minus 1.797 gives us negative 7.97. And we'll continue on with 2 minus the mean, 3 minus the mean, and we have that column covered. Now we're going to take each of those numbers and square them. So negative 1.797 squared is 3.228, and we'll continue that on. Negative 7.97 squared is 0.635, and then the next one is 0.041, 1.448, and we have that column covered. The final column says to take p of x times x minus mu squared. So we'll multiply each of those together. We get 0.052, 0.212, 0.020, and 0.233. Now we're going to add all those together. So the sum of p of x times x minus mu squared is 0.517. That is our variance. And we can take the square root of our variance to find the standard deviation, which in this case is 0.719. Whew. Now let's use this probability distribution to find some probabilities. We're going to find the possibility of randomly selecting a household that has fewer than 3 cars. So just looking at x and p of x, if we want fewer than 3 cars, that's, well, 0 cars, 1 car, or 2 cars. We can just add those probabilities up. We get 0.839. What about the probability of randomly selecting a household that has at least 1 car? So that's 1 car, 2 cars, or 3 cars. We add those probabilities up to get 0.984. And one more, what's the probability of randomly selecting a household that has 1 or 2 cars? So 1 or 2 cars, we add those probabilities up to get 0.823. So that's an overview of probability distributions and what we can do with them. Next time, we're going to talk about discrete distributions, more specifically the binomial probability distribution. Thanks for being here.